All right. Hello. Good morning, everyone. It's 9:30. And for some reason, I'm getting echo on the headset. Okay. Well, I'll turn off the headset. That'll solve that problem, and I'll figure it out later. Okay. So first, I want to apologize for something I just said in chat. I thought it was a private chat window because I'm trying to do 8 things at once right before the stream. If you guys have issues with quizzes, I can fix them, but I can't do it at 9:30. At 9:25, I'm kind of stressed out trying to get all the tech to work, especially for these lectures that require both an online and a that require multiple elements. So like today, I've got animations and all that stuff. If you have issues with the quizzes, please try to take the quizzes earlier. And text me with quizzes. I noticed that there was some issue with Proctorio today, and that people were having, for some reason, I don't know, people have been having troubles with the Proctorio. It's asking for an access code instead of just using Proctorio. I don't know why it's doing that for some people and not for others. So I'm trying to get to the bottom of it. But again, I found out about it last night. I started working on it. The settings are identical to the ones you have already taken. I don't know what's going on. My guess is that Proctorio's got a lot of usage right now, and it's got a bug. But again, these are things I can fix, but I have to know about them. And if you are someone says they know why it's happening. So yes, if you're using Chrome, um, that's the bottom that I could get to, was that you had to be using Chrome. But one of your classmates seems to have a solution to the problem, or at least a knowledge of why it's happening, and hopefully she will share in chat. So I know everyone's a little, stressed about Proctorio, and I don't want you to be stressed about Proctorio, but uh, it's the tool we have. Are there any other issues, questions with that? Let me just respond. Okay, so also I don't know where my TA is. Uh, that sort of thing. Okay. How do you study for the final exam? I didn't post the quiz. The study guide. Okay. So I will get into that. It's basically you study for the final like you studied for the other exams. I'll give you a bootleg. I meant to post it. I didn't, but I did work on it over the weekend. So I'll get it posted. Are there any other questions? And we don't have a final exam yet. Of course, we've got a shortened. Normally everything would be done by now, or at least 2 weeks before the exam. Unfortunately, we have a very shortened because it's only 3 weeks between the classes as three of the tests instead of two. I'm sorry, instead of four. We don't have a final version approved. It's not going to be approved until tonight. So that means the study guide won't be approved until tonight. So we're working on it. And I'm sorry, that's the answer I have to give you. Also, WebAssign, I didn't post it yet. I'm sorry. I will have one for tonight, but it's going to be, of course, the extension policy being what it is. You can do it tomorrow, I suppose, if you want to. But you know what? I'll just make them both due tomorrow. So instead of having one due tonight and one due tomorrow, there'll be two due tomorrow. Let me write this down because I didn't get them posted. There will be two web assigns due tomorrow. Two web assigns for Tuesday. Instead of the one due tonight, and I'll get them posted as soon as possible, probably during office hours or right after office hours. All right, are there any other questions? Okay. The microphone is in the thing it's not supposed to be. Let's see if we can fix that. Okay. Okay. Apparently there's an explanation for this going on um, in chat. So thank you very much, student who posted it in chat. The solution. I cannot mention your name on Twitch, of course. All right. So last time. Oh, by the way, I have a new microphone. Very nice, huh? Okay. So last time we talked about the antiderivatives. Today we're going to talk about why the Romans killed Archimedes. Of course, it's funny. Well, as funny as it can be, considering he murdered the greatest mathematical genius of all time. The Riemann Sums, the formal definition for a Riemann integral, and the integral notation for this AUC thing that we've been playing around with. I don't know why it decided that it wanted the. That's annoying. Come on, Microsoft. Oh, computers are like computers are like air conditioning. They're useless once you open Windows. All right. So we're going to be talking about the integral notation. So any questions? Of course. Oops. Of course, right now it's saying it should say that. Okay. So let's go ahead and let's talk about the quiz from last time. So here's the quiz from last time. State the fundamental theorem of calculus. Well, we did that last time. So let's just do a little, for this rubric, let's just do a little, let's see. How do we see the pages? Oh, they're there. So since we did this exactly last time, what we're going to do is I'm going to come here. We're going to do a little copy. And we're going to do a little paste. How do we feel about this now, 1 to 5? So how do we feel about this statement, 1 to 5? Okay. Now I have a more evil question. How do we actually feel about what that says? 1 to 5, how do we feel about what it means? Okay, so it looks like we're a little uncomfortable with what it means. Okay, let's try to fix that. We'll talk about that some more then, and we'll play around with it some more. Okay, now, this one. How do I compute the general antiderivative of this next one? Oh, great. It's not syncing. Hang on, we got a syncing issue. Okay, well, it's only the most important, lecture of the whole bloody module. Well, maybe not. The one introducing it probably was. And the thing's not syncing. Okay, now it went. Here's to hoping. All right, compute the general antiderivative. So how do I do this? So remember what I said. What you should do is you should take derivatives, not antiderivatives. So if I take the derivative of sine, I get cosine. If I take the derivative of cosine, I get negative sine. And it's not sinking. Okay. Give me a second. It's not sinking at all. Okay. Great. So if I take the derivative of negative cosine, I get positive sine. So that's going to handle that one. Now this f here, this thing I'm going to convert to exponential form. And I'm going to deal with the exponent first. So I've got f of x equals sine of x plus, now this becomes x to the 1/2. So this is going to be x to the 3/2 because I add 1. And then I need to deal with the exponent. Now, in front of here is a 1. So what I'm going to do is I'm going to put something in front of here. And now I can't use the mouse to point because I'm on the tablet live. Let's see if this will, nope. That made it worse. And now you see that because this is why I don't use the tablet. So now I'm going to multiply the front by 2/3. And by multiplying the front by 2/3, that's going to hit that 3/2, and I'm going to wind up with a 1. So now I'm going to take my derivative of this, and I'm going to make sure I get the right thing. So this is going to be negative sine of x plus 3/2 times 2/3 x to the 1/2 plus 0. And this is the same thing as that. So these two things are equal. 1 to 5, how do we feel about that? All right. Is it the points off? Yes. I mean, look at, first of all, you should always take the derivative. Second, I even put it in the instructions. First, you should always do it. And second, I even put it in the instructions. So, yes, it will be points off. If I put it in the instructions, it's points off. Okay. The 2/3 is in front because the 2/3 times the 3/2 would be 1. Okay. And that's what I want in the end when I take the derivative. Or you could say that that's 1 over 3/2, which it is. 2/3 is 1 over 3/2. So if that makes more sense to you, go for it. That's fine. Either answer works. I'll even put that in. That's fine. Okay. Now my next one, I want to compute AUC F0 of pi. So what I'm going to do is I'm going to say, okay, AUC F0 of pi equals by FTC2 and here right now, last time I did it with a G. Now I'm going to do a little bit of notation abuse, okay? It's not actually with this, but I'm going to do just a little bit of notation abuse. I'm going to put capital F here of pi minus capital F of 0. Again, this is notation abuse. This is not actually what I'm doing. I'm doing a G, okay? I'm doing any function that's a member of this set. But, you know, it communicates, right? So I'm going to look up here, and this is negative cosine of pi plus 2/3 pi to the 3/2 minus the quantity f of 0, big F of 0, which was negative cosine of 0 plus 2/3 0 to the 3/2. Okay, so negative cosine of pi so I put a little UR here, and I get 1 for the negative 1 for the cosine, 1 for the sine, I'm sorry, 1 for the positive, 1 for the cosine of 0. I'm going to wind up with negative 1 plus 2/3 pi to the 3/2 minus, now cosine of 0, negative, that bit is 0. Okay, and then there's my final answer. So your formula that you use, the G or the big F, is this negative cosine. It's your antiderivative. Of course, the C's would cancel if I put it in, so it doesn't matter. Or I would say, the other thing I could do is I could say, okay, yes, you could make pi into a decimal, and you could make pi into a decimal, add the thing out, multiply. That would be fine. I wouldn't here. This is a cleaner answer than a whole bunch of decimal approximations. And now you can't actually see me pointing the arrow because, of course, I'm on the tablet, and when I move the tablet thing around, it doesn't show my cursor. So yeah, you could do it that way. Any other questions? Okay, so how do we feel about this process 1 to 5? All right. All right. AUC f prime of 0 AUC f pi of 0 equals negative AUC f 0 of pi by the base change rule. I don't have to say that. This fact is one of those really common ones that you don't have to cite. So the justify your response meant do something that tells me how you got this answer. And I'm lazy and I didn't want to have to do all that work again. So I said, well, I'm using the base chain rule. Okay? And the base chain rule says, well, it's just negative of what I had before. Okay? So, you could have done it a different way. You could have actually computed it out. You could have said the parameters are reversed. That's perfect. There are a bunch of other things you could have said. But yeah, that's it. You could have computed it all out again. It's no fun, but you could have. Any other questions about that? So, how do we feel about that 1 to 5? Okay. All right. This last one. AUC F5 of 5 equals 0. Justification? Because change of x equals 0. Because this has no width. Because of the rule of no width. I didn't go anywhere. I haven't swept out anything. You could have, if you calculated it out, the two pieces would have canceled using FTC2. And that's a fine justification as well. But you could have done it this way. You could have just said, because this has no width. I didn't go anywhere, so who cares? How do we feel about that? 1 to 5. Oops, cancel. No. Sorry about that. How do we feel about that? 1 to 5. Okay. All right, let's go to the graph. Ooh, it looks like the thing's syncing properly again. So let's see. All right, so here I've got a bunch of conditions. Let's talk about these. That first one, f is continuous. I'm just going to write continuous over here. I'm just going to make little notes. As x goes to positive infinity, now it's not sinking again. It's very frustrating to have it not sync. And now you can't see it because the let me see if I can fix the resolution here. There. Yeah, now you can see more of it. You still can't see the whole thing. The resolution that I'm broadcasting at is 1080p, and the resolution that my tablet has is, has a different aspect ratio. So what I see on the tablet isn't what you can see here, and it works fine when it syncs, but it's not syncing properly, so I have to broadcast straight from the tablet. It's going to be one of those days, I can already tell. Anyway, the whole thing's continuous. This says that the limit as x goes to infinity of f of x is 0. So I'm going to come up here and I'm going to draw that thing with some lines. Okay. F double prime of x is less than 0 from negative infinity to 3. So here I'm going to write concave down. AUC from negative 3 to 0 is greater than 1. The limit as x goes to negative infinity is negative infinity. F prime of x is greater than 0 on 0 to 2. F prime of 2 equals 0. And the area under the curve from 2 to x is less than negative 1 from x to 3. This one is hard. Okay? What is that saying? This is saying that I need to accumulate enough area so that what I've done is less than negative 1. Okay, so I need to accumulate enough negative area so that from 2 to 3, I'm less than negative 1, and then negative after. Okay, this is a very hard condition to set up. Okay. Oh, great. All right. If it keeps happening, I may be having to switch to pen and paper. I'm already not going to get to where I need to get today because of all these technical detail things. This has been an extremely frustrating day. AC greater than, I'm sorry, less than -1. All right. Okay, well, let's go to plan C. All right, so plan C is to use this other tablet PC that I have, because I have 2 tablets and I have a broadcaster, and if it doesn't work after that, I'm just going to tell you to watch the video for the next lecture. Okay. Um, so I need this to be less than -1. From here to here. And then after that, I need it to, so from, I can't point because I don't have the ability to point because I don't have it syncing. After that, I need it to be, let's see if it'll sync. Okay, so from here to here, I need it to be less than -1. And then everything after, I need negative. This is very tough. Okay, so let's do it. So I need it to be increasing here. I need it to be concave down. Let's deal with this thing first. Okay. So we need it to come up. Now, we need it to have less than -1 area here. Now, it needs to have a local max right here at 2. So basically, I need to be negative. Now that I'm here, I need to have this right here. This has to be increasing. So what I'm going to do is that I'm going to make this increasing, but it's going to be very difficult to do. I'm going to make this increasing, but very shallow. That gets me this condition here. Okay? Now I need this to have area less than 1. Okay? Now I haven't demanded that, now I need area greater than 1, and I need concave down. So this is all going to have to be positive area here. And I need to accumulate greater than 1 area. So what I'm going to need to do is I'm going to need to do some offsetting. I'm going to have some negative area here, so I'm going to need to offset it with some positive area. All right. So let's see. This needs to shoot up, and I've got no condition that says it needs to be differentiable there. The easiest way to make that shoot up is with a straight line. Okay, it has to be smooth after 0, but it doesn't have to be smooth until 0. And now what I'm going to do is just meet the other conditions. Okay, so now what I have is I have positive area here. There's one positive area. There's more positive area. There's more positive area. There's more positive area. And there's more positive area. So I have the one required, and then I have sufficient positive area to offset this negative area, which I've now acquired. And then what I've got is I've got enough negative area here so that this is negative 1. And now I've got negative area there. And then my negative area, as long as my function stays negative, I'm fine. Oh, you're right. It should go off to infinity. I screwed it up. Didn't say negative infinity? Huh. And actually, this doesn't even need to be... This had less than or equal to, so I could just use a line. Oops. I don't know why I thought it was negative infinity. Maybe my brain's just not working because I'm stressed about all this crap. Okay, there we go. Oh, I know why I was thinking negative infinity, because that's the way it was last semester. Sorry, last semester it was negative infinity. There we go. Is that better? It's concave down because the second derivative is negative. So it's less than or equal to. Sorry, the second derivative is 0 and it was less than or equal to. You could have made it something else to make it concave down. I forgot. I tried to make the thing easier, and I think I made it harder. Anyway. Oh, they aren't synced yet. So I'm sorry nothing's working today, including me, apparently. So that's how you meet that one. And it's a very difficult one to meet. Let's check our conditions. Am I continuous? Yes. Is it the case that my limit is 0 as I go to infinity? Yes. Is it the case that my second derivative is less than 0 from negative infinity to negative 3. Yes, that's true. It's just a straight line. Is it the truth that from negative 3 to 0, I've accumulated at least one green area? Yes. And notice that this is offset. Right? This little sliver of negative area got offset. This is true now that somebody corrected me. Am I increasing from 0 to 2? Yes. Do I have a local max there? Yes. The derivative is 0. And did I accumulate enough area from negative 1 to 0, from 2 to 3, so that I was less than negative 1? Yes. And then I stayed negative after? Yes. All right. So how do we feel about that one, 1 to 5? That one was tricky. Okay. How do we feel about meeting all of the conditions? How do I feel like meeting all of the conditions except the last one? Okay, a little bit better. That last one's tricky. Okay, that second derivative equals 0 here, right? I've got a straight line. That means that the second derivative equals 0. And I can't, again, I can't use the pointer. Oop, the pointer came back because now they synced. This right here, because I've got a straight line, the second derivative equals 0. Okay? Does that answer your question? All right. Okay, I want to spend more time on this graph, but I can't because I'm now at 45 minutes into the class, and I now have to get through an hour's worth of material. Because we've got major technical issues apparently. Okay. So anyway, are there any other questions? Okay. So, and if you're confused about that, by all means, please come to office hours. Please come to the thing Wednesday. If I need to, I'll do a live lecture tomorrow on it. If you want nothing but doing that, I am still doing the Wednesday night sessions. I don't know why no one came last week, but no one did. I was very sad. I was all alone, and now we're about to lose more time because now I have to see if I can get the tablet to come up again without black screening on me. Because I need the other computer for another thing. Okay, so again, no one showed up last time. I understand you guys had chem, and also people didn't turn in the problem set. The not the problem set. The people didn't turn in that too, but people didn't turn in the extra credit thing, the curve. And I really want, if you've missed that, I really want you to turn it in. I want you to turn it in so much that I extended the due date till Wednesday, or the accept date on Proctorio till Wednesday. Because I really, really, really want you to turn in those test corrections, even if you're in very good shape. Because it goes over test 1 and test 3. So, and a bunch of you, I sent you an email if you haven't turned it in yet. I really want that. Okay. Anyway, now I'm really over time for this section. And now this thing came up. This thing came up that I don't need. I don't know why all these things came up when I don't want them. Oh, bugger. Okay. All right, so let's zen for a moment. Calm down. Don't be so frustrated. Remember to turn on the lights. There we go. Let's talk about the stuff we want to talk about today. So what we want to do is today, last time we went over antiderivatives. Today we want to talk about why the Romans killed Archimedes, because he started coming up with this stuff. We want to talk about Riemann sums, and we want to talk about the formal definition of the Riemann integral, okay, which is the notation we're going to use for AUC, and is the way we're going to evaluate AUC for continuous functions. There are other ways to evaluate AUC, all consistent with this idea of a Riemann integral, when the functions have different types of continuity. But the Riemann integral is the way that we evaluate AUC when the function itself is continuous or when it has a finite number of discontinuities. Okay. Because there's a question, why don't I in the future record a video on the quiz? The problem is that then I don't understand what you don't understand. And I know this is very frustrating here, but I actually want to ask you questions about what you don't understand and get the 1 to 5, and then answer questions people have. For instance, that second derivative question I would have never answered if the thing had not been asked in chat. So that's the reason I'm doing the live. I'm just not good enough at doing the videos to anticipate what questions you're going to have, all of them. So I know that's not probably the answer you want, but that's the truth. I'm just not good enough yet to do it without your help. Okay, so Archimedes. Archimedes, interesting guy. Probably the single most brilliant mathematician who ever lived. And he was one of those ancient Roman mathematicians. He lived in basically what's Sicily now. Okay. Ooh, sync is working again. Yes. All right, so he had this clever idea that we went over last time, which was to do things that were based on infinitesimals. Okay, so he had this idea that what we ought to do is talk about what happens when, to evaluate integrals where these things get really, really small. So just to recap, from last time, if I had half a circle, this is what I'd be doing with it, okay? I'd be adding rectangles, and I'd be coming at it from below, okay? So I add these rectangles, and I get something that looks like this, okay? As I increase the number of rectangles, I increase all of the things that are showing. So how do we feel about this concept, 1 to 5? What I'm going to do is I'm going to make really small, I'm going to make a bunch of little small rectangles. Okay. I think I've lost some of the audience because of all the technical issues. Anyway, so that's the idea. I'm going to make this thing by making a lot of small rectangles. Okay. So here's Archimedes, and he's sitting along, and he's trying to explain this. He's working on this thing, right? And the Romans are attacking Syracuse at the time. And Archimedes is this renowned genius. He's also this genius engineer. He built all these war machines that killed a bunch of Romans when they were attacking. So anyway, the legionnaires invade, finally win, because, you know, they're Romans and they're big and stuff, right? And they show up, and here's Archimedes. And the commander, by the way, has given explicit orders that Archimedes is not to be harmed. They want Archimedes working for the Romans. Okay? They are Romans. So Archimedes is sitting there, and one of the legionnaires, the centurions, finds him. Okay? And Archimedes is sitting there trying to explain this to the centurion, right? And he goes, you know, rectangulum infantati. Rectangulum tiny, many rectangulum tiny. Right? Lottie, rectangulum tiny. So for this one, let's say he's looking at this function right here. And he's got 4 rectangles. Rectangulum tiny. And then what he's going to do is he's going to increase the number of rectangulars. So, rectangulum tiny. Lottie, rectangulum tiny. Lottie, rectangulum tiny. Rectangulum infinitati. The Roman centurion's going, rectangulum infinitati. Yes. Lottie, rectangulum infinitati. And the Roman goes, quand the fuci. And then killed. So that's the death of Archimedes. That's the shorter version of the death of Archimedes. So, I want emotes about funniness right there. Make me feel good because I'm rushing it. Now, so what we're going to do is we're going to take a lottie, rectangulum infinitati. Okay? So let's do an example. Let's look at this function here. Exactly. That's pretty much it. Yes. That's how Archimedes got killed. So let's look at a function, okay? Let's look at the function x cubed minus 3x squared plus 5. And we're going to look over it at the interval 0 to 4. Please just work. Okay? Now, what does this function look like? There we go. That's fixed. Let's pull up our old trusty Desmos and put it in. Okay. So here's that function on Desmos. This is what it looks like. Okay. And what we're going to look over is that this interval 0 to 4. And what we're going to do is we're going to estimate the area under the curve. Okay? Is everyone on board with this? 1 to 5. How do we feel about what's about to happen? Okay. So what we're going to do here, let's go ahead and snip this. Let's see. How do we do the zoom in so that it's only on part of it? There it is. And again, I'm not drawing this to scale. I'm zooming in a bit more than I want to. I'm going to do these intervals right here for this function here. Let's do a snip. I didn't get all the function, did I? I should have done 0 to 3. I should have done a function that wasn't quite as big. Oh well. Oh, f of 4 is crap. Is way up here. I should have done 0 to 2. Let's do 0 to 2. 0 to 2 is going to have a nicer thing. Let's change everything to 0 to 2. There we go. That's going to be better. So what we're going to do is we're going to talk about 0 to 2. And we're going to talk about it less largely. So, and this should be, it should be noted. Look at the difference between these dates. Okay. So Bertrand Riemann is the one who figured this out. He's basically the guy who figured out what Archimedes had been talking about. And look how long it took someone to figure it out and formalize it. Okay. So what we're going to do is we're going to estimate this from 0 to 2. 0, 1, 2. So what we're going to do is we're going to start with 2 rectangles. So for 2 rectangles, $2,000 years. Really long time. All right, it just stopped working again. It's not even responding to commands. All right. This is exactly when, the absolute best time for this to happen, right? All right, now it seems to be working again. So we're going to do 2 rectangles, and what we're going to do is we're going to choose the lower endpoint. Of course, this would happen on a day when I can't just use the Of course, this happens on the one day that I can't just go on to paper, right? I've got all these animations and stuff that have to be done, and it's the one day it can't be done on paper and nothing's working. Lower. Seems to be working. So what I want is the lower endpoint. Okay. So for 2 rectangles, what I'm going to do is I'm going to take the min, so lower. What I want is I want the width that's the width of rectangle 1. Now, I want the min f0 of 1 times the width, which is 1, plus min f1 of 2 times the width, which is 1. So this is the width. And these are the heights. Okay. And what I'm going to do then is I'm going to take the minimum value that this reaches. Remember this notation here? This means the minimum. So this notation here, remember that this means the minimum. Okay. All right. So the minimum is this point here. And the minimum on this one is this point here. Now I remember why I wanted to do the other thing. Because now you can't see the fact that there's also a minimum on the other one. So now what I'm going to do is I'm going to count the area of this triangle here and the area of this, rectangle here. And now I'm going to calculate the area of this rectangle here. All right. And what I'm going to wind up with is this right here is the minimum here is 3. And I'm just going to calculate the area of the two rectangles. The maximum, the minimum here is this point here at the end. And so I wind up with an area of 5. How do we feel about that, 1 to 5? Okay. All right, and then what I'm going to do is I'm going to do the same thing here. I do care about the other space, but what I'm doing is I'm taking an estimate. Okay? So let's do it again. This time we're going to do it with 4 rectangles. So now we're going to do lower 4. So 4 rectangles. This is now, each width is now going to be 0.5. So now I'm going to do min f 0, but this time I'm going to do 0.5. This is the height. Times the width, which is 0.5. Okay, that's this rectangle here. Okay, so what I'm going to do is I'm going to draw the rectangle here and then here, and that's that whole rectangle. All right. Then I'm going to do it again. So the minimum here is this rectangle right here. I'm going to have this rectangle right here. And then I'm going to have this rectangle right here. Okay. How do we feel about that, 1 to 5? Okay. Are there any questions about this? So, what I need to do is I need to figure out a way to formalize this. Because what I want to do is I want to take an infinite number of smaller rectangles. Okay? So, in order to do that, I need to come up with a formula. And this is the hard part. And this is always an underestimate. Now, I wanted to do one that would curve up so that you get the fact that I'm always doing the underestimate for this one. Because there's something called the left and the right. And because I had all these technical issues, I'm not going to get to any of them. So you're going to have to watch the lecture from 11 a.m. and there's nothing else to do. And I may even have to do a lecture tomorrow because of all the technical issues that seem to be happening today. Because this computer, because I can't hook it up to the battery and cool it at the exact same time, is about to run out of juice, and I may have to cancel the 11 a.m. lecture and do the whole thing next tomorrow at some time, and then post the video, or do it live and then post the video. And if that happens, I'll announce it. So anyway. So now what I need to do is I need to generalize this. And this is the tricky part. Okay? If I wanted to divide this into n rectangles, how would I do it? Okay? So there's the question. How do I do this for n rectangles? Well, let's see. I want lower, so the question is what's lower n? Okay? Well, it's going to be the minimum. Is everyone on board with that? I'm going to wind up with something that's a minimum. So I'm going to wind up with min f. Now, I need to start at 0. And I don't know where I need to go. But I know my last one is going to be min f something. And I'm going to end at whatever my last thing is. So, not 0. We're going to start at the beginning. For something over the interval 0 to 2. So what I've done is I've fixed x. This last one is going to be at 2. And I know my width. What's going to be my width? Does anyone have an idea about what my width is going to be every time? Well, my width here was 0.5. My width here was 1. Okay? So this right here, this 1, well, I divided it into 2 rectangles. So if I divided it into 2 rectangles, and my width was 1, I'm sorry, my length from the whole thing was 2. That means each rectangle was 1. So my width was, for the first one, each one of my widths was 2 minus 0 over 2. Here it was 2 minus 0 over 4. So my width of each rectangle is going to be 2 minus 0 over n. Now, what are each of these endpoints then? Well, this one here, I'll call this x1. Right? If I want this to be x1, that's this point right here. What am I going to do? I'm going to take 0, and I'm going to add my width. And then what I'm going to do is I'm going to take, okay, and then my question is, so we'll call this x1. I'll call this one x2. I'll call this one x3. And I'll call this one x4. So for x2, I'm going to take x1 and add 2 over n. For x3, I'm going to take x2 and add 2 over n. How do we feel about that, 1 to 5? Okay. All right, here's where I'm going to stop. I'm going to make watching the video for the 11 o'clock, especially, basically the whole thing, because I'm going to fix the technical issues right now. Because I've got 15 minutes, I've got less than 15 minutes before the 11 o'clock class, and I have to fix all the technical issues that happened here today. And I've got to charge the laptop because the tablet seems to be the only one working. So I apologize for that. I will do a shortened version of the quiz, and then tell them to watch the 9:30 video just in case they have all these technical issues again. So that's it for today. But you are responsible for the stuff that I talk about in the 11 o'clock lecture, but you can do that, and that will have to be part of your notes. Is everyone on board with this? I'm sorry of all the technical issues that seem to be happening with Proctoria, with all of this stuff. I don't know why the internet just hates us all today, especially me. But those are the technical issues. If you didn't already submit your test corrections, please do so. Also, if you want to request regrades for the test, those are still open. Please do it through the regrade system. I've seen some emails. It's really difficult for me to jump to those questions. It's much faster if you do a regrade request because then it takes me right there. Are there any other questions? Okay. Again, I apologize for the sloppiness of today because apparently everything hates me. And I will see you all next time. And if you have any questions, I do have office hours at 12:30.